started. This is the 210 session using Optparse, Subprocess, Doctest, make annual Unix utilities. Here's Noah. Noah's a software engineer from Atlanta, Georgia. He works for Gracie. He's currently co-authoring a book on Python for system administration for Orion. So without further ado, Noah. One problem I've run into is I actually can't get on the network. So a part of what I was doing was demonstrating some different tools, but you'll just have to take the word for it. For the people that are on the network, you can actually download the presentation at tools.nodegif.com, Python 2008, or just go.nodegif.com. It's there as well. Can you guys hear me? No. Oh, is this a little better? Yeah. Okay. So you can download the code at code.nodegif.com, Python 2008, for the people that are actually on the network. And there's source code and a PDF for this presentation. So, okay, the talk is on creating agile Unix command line tools with Python using Subprocess, Optparse, Doctest, and more. So for the people that are on the network, quick warning, one of the examples is going to show how to discover a network in about 3 seconds. You can ICMP request, so don't do that. Like, wait until you get home and do it on your neighbor's wireless access point. We're having problems, that's it. So for people that haven't written a lot of command line tools, maybe you write command line tools, the Python standard library is just insane. The command line tools didn't come through. Optparse is just ridiculously easy. Subprocess is a one-stop shop for simplified API that makes systems calls. Configparse, you can write INI files, read and write them quite easily. You can throw in concurrency with threading in queue. And yesterday I went to the tutorial with David Beasley, and he showed some just insane examples of generators. And finally, you can also use Doctest and Python 8 with entry points. So you kind of have this just incredible tool set to make Unix command line tools. It's amazing that more people aren't doing it. But I've seen some command line tools like Bizarre, etc. There's definitely some people doing this, but it's just for what Python has, just standard library alone, it's amazing that there aren't more Unix command line tools. So some ideas for command line tools you can make in Python are just pure Python command line tools. There's so many libraries that you can use, it's ridiculous. You can also make Unix mashup tools. So everyone's talking about Web 2.0 mashup tools. This is kind of an interesting thing. Is mix, use subprocess, capture the standard out, and do tricky things with regular Unix tools, and then mix Python technology inside. So it's kind of the Unix mashup tool. You can make this pure network tool. There's all kinds of incredible networking libraries. We're going to talk about one of them, which is called Safety. I don't know if anyone's ever tried that, but it's insane. And then also, one of the things that I like to do is I'm really lazy. Sometimes if I don't like how a command line tool, like it has too many options, or it just seems like too verbose, I'll just wrap it up and put the default options. I don't really use an edit tool, or I'll make a config file. I'll make a config file, .ini file. So really the basics, without going really crazy on the standard library, just some process and Optparse. Chocolate and peanut butter. Alone they're good, but together they're an 8. It's really, just that, those two alone do incredible stuff. So kind of some sub-process tips for lazy people. I know a lot of people are still getting used to sub-process, although it's been around since Python before. If you don't care about standard out, just use subprocess.call. And I'm going to show a really interesting example of you can actually pipe subprocess.call to death roll if you really don't care about standard out. You don't want it to display. you just throw it to dev null and look at the return code and get if it's 0, okay, yeah, I can go on to the next thing. If you want to do something with standard out, just use subprocess.q. So hopefully that, I think that actually looks reasonable, so people can see it. Although you can also download the source code, look at it while we're talking here on the network. Basically, in this example, I'm wrapping up ping command, and ping minus c count 1 works on almost every Unix box. Probably works on Solaris, AIX, OS X, Linux. And so in this example, I don't care at all about the standard out. So I'm piping it to dev null, and I'm looking at the return code. And if I get a 0, that means yes, the device is alive. And if I don't, I don't respond. So this is kind of an example of how to use the subprocess on call. And as I was mentioning earlier, if you haven't used Optparse, it's just incredible. So this is an example of Hello World and Optparse. It's just ridiculous how easy it is. Let's actually, let me just type that in real quick so you guys can see what this, like, 6 lines of code is. Here's a really simple hello world, and one of the cool things about Optparse is you get all this stuff for free. So here, if you just type in help, you say, oh, look, I have a help menu. And if you try to type in something that, an option that doesn't exist, like, food, it'll go, I don't like that option, it doesn't exist. So you get all this stuff, just, you don't have to do anything. Just, if you've ever written something in Bash or C, it's horrible. I mean, you have to write all this stuff yourself, and it's free. And so that's one of the really interesting things about Optparse. And let's go to the next slide. And so here was the thing I was going to show where we discover a subnet in about 3 seconds. So it's probably good anyway. It probably would have done something fancy. Took the one person of the network off. So basically, in this example, we're going to wrap that ping command that we showed you, create a queue, response threads, and that's really it. And here's kind of what that would look like. I don't know if you can, does that look readable to some people? No, it's like, so in a nutshell, we just took that same ping function, created a queue, and then pull a bunch of threads to wait on that queue, and then just put things in there, one at a time. And so that's one of the, this isn't really about command line tools per se, but it's one of the interesting things about you're taking a system call, which is everyone takes for granted, you're taking ping, it's like the most basic command that almost everyone has run, and then you're taking this sophisticated writing library, queue, and you can turn this into an auto discovery system for a network. And that's kind of one of the examples of the power of taking some really simple command line tool that's almost obvious, and then using all the crazy stuff that Python has to offer. Actually, this example will be good because I did not plan on having a network for this. So let's run that. Now, is the text big enough, or is this pretty small too? Bigger? Okay. How about that? Good? Okay, let's, good? Okay, perfect. All right, so this is an example of, I know a lot of you couldn't see the code, but all it does is have a list of IP addresses and I have that ping function that I showed earlier, and a pool of 4 threads. Each one of them grabs an IP address off the list, and then if it responds, it gives you back a response that says, I responded, if not, do not respond. I mean, that in a nutshell, the whole discovery thing. And you just make more threads if you want to run quicker. Let's go to the next slide. And so, apparently, some of this could be a little bit difficult to read, but the next step is you can just use Optparse to handle all of the IP address and threading options. So basically, if you do in this example, we do a -n or a dash number, and I could modify the number of threads that run. And since you guys can't read the code, let me just run it, and it'll still work. Just nothing's going to be discovered, and it'll be kind of interesting to see that thread spawn. It's kind of fun. So let's do that. I'm actually, since I wanted to do something fun, because we don't have network access, I'm going to show the threads as they can spawn. So, I mean, that's it. I mean, that's like incredibly simple how you can kind of take something for granted and then create this crazy structure that launches massive amounts of threads. It was pretty easy. It's not that bad. And this actually, if we let it run for a bit, each one of the threads is going to try to think something. It's going to come back with a response that I couldn't find anything. So actually, I think it'll be about 5 or 6 seconds per thread. So it'll probably be done in maybe a few seconds. And so what we can do is we can actually let that keep running, and then I'll go back to my slides and come back. So theoretically, if we got responses back from that, you could do something interesting, and you could use another command line tool to kind of chain these things together. And so after you get a valid response, you put those valid responses in another queue, and then you could run something like SMP walk, which is on almost, I think that's on almost every machine, unless you're running a stripped down version of Linux. And so you could say for every valid address, let's do a SMP walk, and let's do something simple like system experiment. So basically, you're just taking these really little bits of tools and chain them together to make more sophisticated tools. So what would that get us? It would basically enable us to do a very simple discovery of a network by pinging all addresses, and if the address comes back positive, then put that in another queue, have another set of threads waiting on that queue, and then do a simple SMP walk. And then so you've got some kind of really basic, powerful tool in whatever, just half an hour, however long it takes to write it. So you can just keep on doing fun things like this. Maybe, I don't know, maybe you want us to discuss all the Linux boxes, maybe you want to run RPM update, so you can then chain it with another command that SSHD is enabled. If you have SSHD enabled on all the machines, for every Linux box that comes back and it has, I know that Red Hat, I want to do RPM update. That feels maybe a little dangerous, but you can do that. And actually, if we go back and we look at the output of the command, which should be done by command. So we discovered the network in 66 seconds. So that's actually kind of an interesting test. So basically, if you, I think there's 50 threads. So each one of those 50 threads had to keep going back to the queue queue when it was done. And so it took about 66 seconds to find out that 255, or I think however many usable addresses, 254 usable addresses, were not alive. Yeah, so I know in the title I talked about Doctest, and so another kind of interesting thing you can do is you can put really simple Doctests inside of some of the functions or methods, and then you can use, I don't know how many people have done this, but you can import Doctest, and then you can tell Optparse to run Doctest. So it's kind of an interesting idea. I don't know if it's clever or not, but I kind of like doing it where when you write your tool, you can actually run your tests, and then the tests are living inside of your tool. So it's kind of an interesting way to think about running command line tools where you can distribute this to somebody and they don't have to do anything extra to know that most of it works. Because you can test most things, but not everything with Doctest. But it's kind of an interesting idea. So there's an example of this in the source code as well. I know this is probably hard for some people to read. And let's go to the next. Yeah, I can. Let's take a look at it. So yeah, actually that probably looks a little bit better. So this is actually not a complete test by any means. This is just testing that you can create a queue and you can put something in it and things don't bark. And there's a function called _test that imports Doctest, runs doctest.testmod, and gives it the verbose option. That's kind of a nice little idiot if you weren't aware of it. And so if we go down to the test here, when someone runs the tool, and actually let's go ahead and do that. If someone runs the tool, they can actually run your test. So that's kind of cool. I don't know. Well, I have 2 tests. Of course, they're really cheesy, but you could fool some people. And that's what's important. Maybe it would get you a job whenever you say you're an agile developer. So I'm actually getting, that was a good example. Thanks, Shannon, for helping me out with your. I'm just going to show this from them from now on. But here's an example of a pure Python tool. So this is kind of going into a little more of pure Python stuff, but there's this library called Scapy that does all kinds of crazy network stuff. And I decided, okay, let's use an object relational mapper. I just flipped it on. I'm not taking sides on which one's better, but okay, we'll use storms, and then I'm throwing out parts in it. So in this example, I use Scapy to get all the IP addresses and all the MAC addresses from a network, and then I create an in-memory database, and then I use I then print out one record from the database, and I'm using Optparse to handle taking care of the options for the subnet. So actually, let's take a look at that really, really quick. I think I've got about 5 more minutes or so, 10 more minutes. Okay. So kind of, well, what's really interesting about Scapy is that it's just ridiculous what you get out of it. Where we actually did some cool stuff where we had to chain all these queues together, but it's all included inside of Scapy. And so you can actually, if you use just this function and you ran it on a subnet that was live, you could get the MAC and IP address in like 3 seconds. Just get it back. And down here, I use that in-memory database above to pull a record out and print it out. And so I'm actually not going to run this because nothing's going to come back. So, because because I'm not attached to the network, but it's kind of an interesting idea to take network things, mix them with ORM, things like that. And so another really powerful thing you can do with creating command line tools is integrating config files. And, for some reason, some of the Zope people, like build out, for example, does this. But it's amazing how simple it is to actually write a config file and then parse it and then put that inside your command line tool. So if you have just an incredible amount of chain things inside, and you have 5 options, and you're scrolling over like 6 lines just to get your tool to run. Put a config file together and parse it, and then somebody can run all the really tricky stuff, and then only control the things they really want. And I'm going to run this example because it doesn't require the network. So really simple config file. And boom, that's it. It's that simple. You just use that to handle the input instead of taking it from the camera. I know I'm getting down, so I only have a few more minutes before questions. So let me kind of slide through this. So, actually, I'm actually about to. So the edit if you're in the writing command line tool and you have not used an interest yet, it is awesome. And so all you have to do is create an entry point that looks something like this. And when you create this egg, somebody does anything install, it'll just automatically throw whatever you told it to call into the script that's put inside the scripts directory. And it's just amazing when if you've never done this before, you just make an egg and upload it and then install your egg, and you're just like, wow, I have a command line tool. It just knows how to work. And what's really, really interesting about this is that you can obviously do something kind of tricky. I haven't done this yet, but I want to do this, is add a dash upgrade flag to your command line tool, and just use setup tools to automatically add the new version of your egg, and then it'll upgrade the entry point in the already existing script you have, and basically you can do like a software update in the command line tool. And so I haven't done this yet, but when I get some time, I want to do this. That's kind of a really interesting thing you can do. Setup tools are just amazing. So that basically we're about finished. So here are some of the references for some of the things, and hopefully you can get on the network and download and play with some of the stuff. But yeah, try not to play with anything that does massive pings. It's just probably not very nice. Okay. So you basically have to write a setup.py, and I created a fake entry point, and so basically you have to define console scripts, and you just say basically the function that needs to be called inside of your module, and it'll just run it. Yeah, because I haven't used that. What was the? That's one thing I have not really gotten into that much, but PageScript was really it simplifies a lot of the setup tools and stuff for you.
Yeah, how you doing? Good. I'm just wondering, based on what we have with the tools and you're doing the multi-threading or whatever, and you're responding to all these threads, how do you handle home command line processes that are used to
So, I'm sorry, how do I do what?
handle home command line processes, say you're doing a ping or maybe something else that it's just not returning a result?
Well, I mean, one simple thing you could do is you could put something like an add exit, and you could make sure that you do a sys.exit 0. That's one way of kind of saying if somebody tries to stop, because that is one of the things that's nasty about threads is if you do Control C, you'll just get all these weird, there's all kinds of errors that come out. And so if that happens to you, you can do Control / and it'll actually kill everything. But generally you can. I didn't include all the error handling, but usually a sys.exit will kill the thread. It's the same as telling the thread to go away. Cool. What's it called? Oh, okay.
Other questions?
I was watching there. Oh, so one of the questions was, I know a lot of people have had problems with if you're using Subprocess as like a pipe deadlock, basically. And so I saw there was an update to Python 2.5 that I think there's some things about Subprocess that fit. I'm not entirely sure. I know that that at our company, actually, I don't think I'm giving away any secrets. We just wrote it out to the file, and that was our way around it. Yeah.
One more? Last one?
I just wanted to mention that you can use this type of thing as well for Windows network administration, and it will completely blow the minds of standard Windows administrators.
Yeah, I didn't get into the SNMP. I think we're almost. I didn't get into the SNMP part, but yeah, that SNMP is where you can just completely cross-platform. You can do just not the SNMP control devices.
You know what